And the next talk is the systematic change of metamorphic conditions along the collision belt relating to slab breakup, and by Chang Whan Oh.
그 위에서 보는 거 같이. 또 끄고 뺄까? 들리지 않을까?
중간에 이거 시원찮은 그냥
이게
나를
그게 전진
그런 건 나는 설정 안 해요.
여기서
For me, the 100 kilometers depth is very deep, but yesterday and today I found it was very shallow in this meeting. And anyhow, my talk is related to some shallow depths for you. First, I will talk about already the metamorphic pattern around the Davion collision belt between the North and South China block. And secondly, I also review briefly the metamorphic pattern around the Himalayan collision belt. And finally, I'd like to suggest technical models which explain the different metamorphic patterns for the two collision belts. Before I start my talk, I briefly explain about the importance of eclogite. This is cartoon for collision between India and Asia continent. Before collision, there was a subduction of oceanic crust. Eclogite formed only in the subduction area. And during collision or before collision, the eclogite moved up to the surface. So if we find the eclogite within the continental crust, it means there was a continental collision. In the late 1980s, Triassic eclogite found in Davi Chinning Belt in China. Based on this, the collision between North and South China blocks was initiated. After that, many geologists wonder whether this collision belt will continue to Korean Peninsula or not. For a long time, many people think Injingang belt may be the extension of Davi's collision belt, but unfortunately, no evidence was found from the Injingang belt. Instead, we found Triassic eclogite in the Hongsong area further south. So we confirm the extension of collision belt to Hongsong area by finding the Triassic eclogite. And these are the technical models suggested previously. This is Inenni's model, where the eastern part of South China block extruded and collided first. So during the initial collision, the tunnel fault formed here in China. And then Inenni suggests the Honan Shoujo in Korean Peninsula may be the partner of this tunnel fault. In the case this part became South China block and the other part of Korean Peninsula can be maybe the North China block. And this is the model suggested by Zhang. He mentioned about the late Paleozoic subduction complex in North Korea, and he suggests the collision belt will extend to the North Korea. And this is the model suggested by the Ernst and Louis. They suggest that it will pass some part of Korea and maybe extend to the inner part of southwest Japan and go to the Shikoku Island area. And this is another model suggested by Ishiwatari and Ishiwatari. He suggests the collision belt move down to here and continue to Japan due to the Triassic high pressure rocks. In this case, the whole Korean peninsula became North China Craton. In these two cases, northern part of Korean peninsula will be North China Craton, southern part of Korean peninsula may be the South China Craton. When you apply the finding of eclogite, we can exclude this model. And recently, the initiation age of Honam Shojon proved as 190 million years old. So these two faults cannot be paired. So the Inanese model also have some problem. So the remaining thing is whether the collision belt will pass through the Korean peninsula, and after, to where it will be continued. And in the eastern part, we found the Triassic post-collisional granite, mangarite. In here, there is a K-feldspar and OPX coexist. And after that, I and other researchers found post-collisional igneous rock in Korean peninsula. This is the first place to find, and we also find even in the southern part of North China. And these are the chemistry of these rocks shows they are all post-collisional igneous rock. And the age is almost same, Triassic. So this is the model for the post-collisional granite. First, the subduction of oceanic crust under the North China Craton. And the subducted oceanic crust pull down the continental crust to some depths, where the buoyancy of continental crust is stronger than the pulling force by the subducted ocean crust. The slab lake occurs. Through the slab lake, through this window, the atmosphere moves up and supplying lots of heat, which causes extensive magmatism, post-collisional magmatism in the North China Craton site. So we found this kind of post-collisional igneous rocks here. So we can say this might be the boundary between North and South China Craton in Korean Peninsula. And this belt may be further extend to the Japan and to North Korea. This is a simplified geologic map of Japan. So this is a Paleozoic subduction complex. So Paleozoic subduction complex formed around the North China Craton before collision. And this is also early Paleozoic continental margin. So this may be formed around the North China, around the subduction formed around the North China belt. And also, in here in North Korea, the Yanji belt formed. This is also late Paleozoic subduction complex, Carboniferous Permian subduction complex. So this is the simplified model. After North and South China rock are separated from the Gondwana, they move up toward north with this kind of shape, and subduction zone formed around the North China Craton and collided first in the Korean side and propagated toward China and completed in the late Triassic. During this time, the Japan may be located here. And they may be moved down to southwards. And I expect, although I did not study, but I expect some dexterous fault between Korea and Japan, which may be the pair of tunnel fault, which will move down, which may have moved down to Japan to the southwards. And here we found ultra-high temperature metamorphism. So these are the mineral assemblies which indicated the ultra-high temperature metamorphism, which occurs with post-corrosional granite. We got very high temperature, higher than 900 centigrade. And it occurs in 245. It means Permian. So this is the summary of a metamorphic pattern around the Dabi-Hong-Song collision belt. In Dabi-Suru area, it has undergone ultra-high pressure metamorphism, very high, at about 220 million years ago. In the Hong-Song area, where we found the eclogenic Korean peninsula, it has undergone high pressure metamorphism at about 240 to 230 million years old. In Odessan area, easternmost part, we found ultra-high temperature metamorphism at the 245 million years old. So the metamorphism starts from Korea side, propagated to China side. So this is the summary of a PT pass on the collision belt. This is Odessan, Hong-Song, Dabi-Suru. The pressure increased toward west, and the peak temperature decreased toward west. There is some patterns. So let's move to the Himalayan area. So ultra-high pressure metamorphism found in the western part of the Himalaya with eclogite. But in the Middle Eastern part, only high pressure eclogite found without ultra-high pressure metamorphism. And easternmost part, there is no high pressure metamorphism. We found high pressure granite-like facies metamorphism. So the summary is like this. In the western part, there is an ultra-high pressure metamorphism at around 55 to 45 million years ago. In the Middle East, there was only high pressure metamorphism at about 30 million years ago. In the easternmost part, the high pressure granite-like facies metamorphism at about 22 to 25 million years old. So it means in Himalayan case, the collision started from the west and propagate to east. So this is PT pass in the western part of Himalaya and Middle East and eastern part. In here, the pressure also decreased for the east, but the peak temperature increased for the east. So in both belts, there's some metamorphic patterns. Before collision, between North and South China Craton, there's a very small ocean in the east side, but the ocean increased toward the west. It means here, the subduction of ocean across the amount of subducted ocean crust is not is small, but in China side there is more amount of subduction of ocean crust. But in India and Asia case, there is a very big ocean. So in collision belt between North and South China, it collided from east. At the initial time, the amount of subducted ocean crust is not enough to pull down the continental crust to the depths of high pressure metamorphism, high pressure metamorphic depths. So slab opening occurs very shallow depths, which cause very high heat to the North China, the bottom of North China Craton. It causes extensive post-corrosional igneous activities and very high temperature metamorphism. But in the neighboring areas, there was still continuous subduction due to the amount of subducted ocean crust is enough to pull down the continental crust. So in the Hong-Song area, the slab break occurs at high pressure depths, but in Suru-Dabi, still there is a subduction due to the more amount of subducted ocean crust. And the slab break occurs in ultra-high pressure temperature metamorphism. So this kind of ultra-high temperature metamorphism occurs here due to the heat supply from asthenosphere through the shallow slab break-off. And this is Hong-Song area. And in the Dabi-Suru, the continental crust is subducted to very deep depths, so it can reach it to the ultra-high pressure metamorphism. And let's move to the Himalayan collision belt. There was enough oceanic crust before collision, and the collision started from the western side. The amount of subducted oceanic crust is enough to pull down the continental crust to the ultra-high pressure metamorphic depths. And then the slab break began to occur here, and then the slab break propagates toward east. So in the Middle East, the continental crust only subducted to high pressure metamorphic depths. And finally, slab break occurs in the easternmost side, and the continental crust failed to subduct to the high pressure depths. So this kind of pit paths also are explained by this kind of tectonic model. So the conclusions are like this. The metamorphic pattern along the Dabi-Hongsun collision belt changed from ultra-high temperature through high pressure to ultra-high pressure metamorphism toward the west. In Himalayan belt, the metamorphic pattern changed from ultra-high pressure to high pressure to high pressure granular faces toward east. So this kind of different metamorphic pattern is related to the amount of subducted oceanic crust before collision, and also the depth of slab breakup. So by studying the metamorphic pattern around the collision belt, we can figure out what kind of collision process occurs around the collision belt. So it can be applied to other areas. Thank you.
Sorry, but most fundamental point, you list the geochronological data set. For example, Himalaya, there is a, most important thing is you should use spot dates of zircon, which contain calcite. Rim contain low pressure minerals, and granite and amphibole is just overgrown, -25. This is true to the western end of Himalaya. Kaneko-san has did example work. You should look at. So the core is 48. Barovian hydration data 25. Same to the east. So Derby is so in the Derby, the core of ultra high pressure including calcite is 240, mantled by 220, always 20 to 30 million years difference. That is the meaning of UHP events, followed by hydration event. Same. So the both original belts, we cannot see any tendency. Just difference. At the same depth, same location, 280, you must differentiate. This is the first one. Okay. Eclogite cannot be formed. Can be formed in both belts. I have proposed a classification of eclogite by prototypes. In both, any original belts, always consistent with passive margin deposit, alkaline basalt by Ronald Walker. Those prototypes is metamorphosed at high pressure, ultra high pressure. So that therefore, eclogite in Himalaya and Darius not Pacific type. This second, probably add 5 more doubts and wrong, and I'll discuss later. The reason why is I was an actual supervisor of your session. That's the reason why I strongly criticize.
Okay. So I'd like to suggest to read the reference in the Himalayan area first. Because as you mentioned, in the western area, the quartzite bearing zircon gives the age of 55 to 45 million years old. And in the Middle East area, there's no quartzite found. So if you say the ultra-high pressure metamorphism can be erased completely, then how? UHP metamorphism preserved in the western side of Himalaya and Dali Sur. Yeah. So what I mentioned is I'm talking this result with the mineral assemblage observed in around the Himalaya area. Most people do not care about it. So many people just think ultra-high pressure might occur around the whole collision belt, but it's not true. So we have to change that concept first.
No. Absence is impossible to be demonstrated by science. This is the limit of science. You must consider such kind of philosophical background.
So
absence is impossible to demonstrate.
So maybe we have to discuss in personally because anyhow, so this is based on the previous study. So if this is wrong, all paper might be wrong. So you should criticize all papers published in the Himalaya collision belt. So this is based on the previous papers in around the Himalayan belt and the Hongsong Dabi area. That is, I can give you the short answer. Otherwise, it became long.
Okay.
No, not that. So another question for the Dabi Hongsong collision zone. So if I'm happy if the UHT metamorphism is incorporated to the same system to the UHT metamorphism. But the age of the UHT metamorphism several tens million years before the high pressure metamorphism, is right?
Yeah, 15, yeah, around.
So is it okay to consider to the your model?
So
the first collision started and then later it takes so long. My impression is so long. Too long.
yeah, you think it's too long? Yeah. So that is some problem I have to solve. And the ecological age I got from Hongsong might be older than 230. The 230 age might be the granular facies metamorphism. So the age of ecological Hongsong area might be 240, something like that. So, but I have no time to confirm it. So I just mentioned the time of ecology 230 years, but it may be older than that. But I have to study more to confirm it.
Okay, thank you very much.
Okay, so we proceed. So we have only 4 more talks. So we decide if you want a coffee, you can take a coffee. We already prepare the next talk, and we don't really stop. So we have like in 1 hour and 20, we can start again with discussion, and then we can relax a bit. So